What if I told you that our solar system isn't what we think it is? That beyond the icy veil of Neptune, in the pitch black, a world similar to our own is hiding? Not a gas giant, but an Earth-sized planet that has so far eluded our most powerful telescopes. Sounds like science fiction? Maybe. But a new study that has shaken the astronomical community suggests just such a possibility. And no, we're not talking about the famous Planet 9. We're talking about something new. Something closer. Welcome to our channel. Today, we're diving into the coldest and darkest corners of our cosmic home. An article in Live Science has drawn attention to a new, bold theory. It suggests that the ninth planet, or 10th if you count Pluto, although let's not get into that, might not be a huge giant, but a rocky world hiding much closer than we thought. To understand where this theory comes from, we need to travel to where there's almost no sunlight, the Kuiper Belt. It's a vast junkyard of icy debris, comets, and dwarf planets orbiting far beyond Neptune. For decades, astronomers have noticed strange things here. The orbits of some of these objects, which we call Trans-Neptunian objects, or TNOs, are behaving incorrectly. First, they are strangely clustered. Imagine throwing a handful of pebbles onto a spinning disk. You'd expect them to scatter evenly. But these objects stubbornly stick together, as if being herded by an invisible gravitational shepherd. Second, and this is the key point, many of them have an extremely high orbital inclination. That is, while all the planets, like Earth or Jupiter, orbit the Sun on one plane, like a record, these objects are flying at strange, chaotic angles. Something has pushed them out of the dance. For a long time, the main suspect in creating this chaos was the so-called Planet 9, a hypothesis pushed by astronomers Mike Brown and Konstantin Batygin. Their theory suggests a huge world, 5 to 10 times more massive than Earth, hiding at an insane distance, perhaps 400 to 800 times farther from the Sun than we are. But this theory has problems. It explains the clustering well, but it can't fully explain the large number of TNOs with high inclinations. And this is where Planet Y enters the scene. Astronomers Patryk Lykawka of Kindai University in Japan and Takashi Ito of the National Astronomical Observatory of Japan published a new study in the prestigious The Astronomical Journal. They spent thousands of hours on complex computer simulations. Their conclusion? You don't need a massive giant to explain the anomalies. Their model shows that all the oddities of the Kuiper Belt, especially the strange inclinations, are perfectly explained by a planet that has a mass of only 1.5 to 3 times that of Earth, meaning it's a super-Earth, a rocky world like ours, just a bit bigger, orbits at a distance of 200 to 500 astronomical units. Let me explain. 1 AU is the distance from the Earth to the Sun. Neptune is at 30 AU. The classic Planet 9 is at 400 to 800 AU, and this Planet Y at 200 to 500 AU. It's still incredibly far, but significantly closer than we were looking before. So what's the proof? That's the main question. We can't see it, after all. The proof is in the simulation. Gravity isn't an instant force. It takes billions of years for the faint influence of a distant planet to change an entire system. Lykawka and Ito's model shows that a planet with these parameters, orbiting at an inclination of about 30 degrees, would, over time, literally pull the small objects of the Kuiper Belt into the same strange trajectories we observe today. What's more, their theory also explains the existence of strange objects like Sedna, a dwarf planet with an incredibly elongated orbit that takes 11,000 years to circle the Sun. The presence of Planet Y stabilizes such bizarre orbits. It's the missing conductor of this chaotic orchestra at the edge of the solar system. If it's there, and it's closer than Planet 9, why haven't we found it yet? The answer is simple. Space is incredibly large and incredibly dark. At a distance of 500 astronomical units, sunlight is so faint that this planet, even if Earth-sized, would be colder than Pluto and reflect a minuscule amount of light. Finding it is like trying to see a black bowling ball against black velvet from hundreds of miles away at night. Our current telescopes, like Pan-STARRS, scan the sky, but they're optimized for other tasks. We might simply be looking in the wrong place, or the planet is just too dim for them. But there is hope, and it has a name: the Vera C. Rubin Observatory in Chile. This next-generation telescope is a true monster that will change our understanding of the night sky. Its mission is to do what no one has done before: photograph the entire visible sky every few nights. Its main goal is to find everything that moves or changes. If Planet Y exists, the Rubin Observatory is our best chance to find it. It will capture that faint pinprick of light crawling against the background of distant, stationary stars. Think about it. We've landed robots on Mars, sent probes beyond the solar system, but we might not even know the full roster of our own planetary family. Discovering another rocky world, a super-Earth in our own backyard, would flip our understanding of how solar systems form. Is there an icy super-Earth hiding in the dark? The Planet Y theory isn't proof, but it's a compelling scenario, and most importantly, a treasure map for future searches. The darkness at the edge of our system holds secrets, and we are about to turn on the light. What do you think? Is Planet Y real? Will we find it in our lifetime? Write your thoughts in the comments, and if you enjoyed this dive into a cosmic mystery, don't forget to subscribe and hit that bell. See you in the unknown!